In this video, we will be demonstrating the Equine Infectious Anemia Virus Antibody Test Kit from VMRD. Now within the kit, we are given two reagents. Reagent A is our antigen, and reagent B is our reference positive control serum. Now not included in this kit, but required, is a agar gel, which I have here that's pre-cut. You will need pipette tips, a pipetter, and also some kind of light source. And this test actually takes 24 hours to incubate, so you would need some kind of humidity chamber or an incubator that's set to 22 degrees Celsius, because this is a very sensitive test, and if it dries out, then you're not going to get a good reading and you'll get a false negative or just invalid result. Now, to start this, I'm actually going to label the back of my plate here. The center, we're going to put our antigen, that's A. In the top is going to be our patient sample. I'm just going to put a dot to signify the patient. This well, I'm going to call it positive, and this is negative. Now my negative is just a serum that I have that I don't believe currently has any EIA in it. Positive is really a reference serum, so we're going to be filling 4 wells with that reference serum. So to start, I'm going to need about 50 microliters, but really we want to make sure that we fill the well completely, but not overfilled. So A. And I'm actually going to do this on a black background. That looks better. And we're going to do the same thing to the additional wells. I'm going to go ahead and put my positive control in, not my positive control, but I'm going to go ahead and put in my patient first. And we want to make sure that we have a positive control on either side of our patient samples. And now the reference serum, which is also known as our positive control. Okay, so now that the plate has settled a little bit and reached at the bottom, I've got this Tupperware container that is, you know, comically too large for our plate, but hey, if you're running multiple plates, then you'll have plenty of room. So I've got paper towels in the bottom, and I'm just gonna drip some water in to make sure that it's a humid chamber. We don't want, the whole point of this is that we don't want that plate to dry out overnight. It is a 24-hour incubation, and depending on the room temperature fluctuations, we don't want anything to mess with this test because it is extremely sensitive. So we're gonna do as much preparation as we can. So I'm gonna put just some dry ones on the bottom and gently place this plate back in. We did some precise pipetting, so you know, we don't want to mess any of that up. I'm gonna get my lid and put it back on there, and this can stay like this undisturbed for the next 24 hours. Now when you go, you know, don't worry about popping it out, because once the test is done, it's done. So if we disturb the wells upon opening this tomorrow, it's all right. It's not the end of the world. But this is it. We will check back in 24 hours. All right, so I have two different viewing instruments for this because I realized after filming that it wasn't showing up very well. What we have here is a plate reader. There is a black background and a nice narrow beam of light that gives us light from underneath the plate, which is what we need to visualize these bands. And on top, we have a magnifying glass just in case you can't see it. However, after warming this bad boy up for a few minutes, this particular beam of light is bright enough to visualize it. So we'll go from here. This is what we actually typically use in parasitology for our dissecting microscopes. So I've got my plate here. It's been 24 hours. And boom, there we go. We have a positive sample.